Hi, I'm Barry DeBruin with the Middleware Academy, and today we're going to be reviewing how to do 270 5010 to 4010 and 271 4010 to 5010. This is often called the step up and step down approach, and the situation that a lot of insurance companies are finding themselves in is that they're going to have to receive 270 5010 files, but they don't want to change their back-end system. So what they want to do is they want to rely on the middleware guys to go ahead and step this down to 4010. So they want a 270 5010 transaction coming in the door, and the back-end system they want to receive a 270 4010 file. So this isn't a problem for WTX. IBM ships with the HIPAA trees. So you have a 270, you have a 271, you have 5010 and 4010, so it shouldn't be a problem. But the one issue that people are facing is the EQ segments for the 270 5010 and the EB segments for the 5010 271. So 5010, the new rule allows for multiple service type codes, as you can see here in UltraEdit, to come into the EQ segment. 4010, however, doesn't allow this. So 4010, you have to have each service type code on a different EQ segment, or EQ loop. So in order to do this in the map, what we need to do is use the clone function. So as you can see here, we have a 270 map. It's 5010 to 4010. And if we go down to our 2000D loop, we can see the EB loop getting triggered. So the EB loop is getting triggered by each dependent, or each EQ segment, except for we can see that we use the clone function. And why would we do that? The reason why we're doing this is because we want more EQ segments on the output than we have on the input. So the clone function is very nice. It'll allow us to clone the input data as many times as we have a certain number. And in this case, we know the number is going to be the number of service type codes. So however many service type codes that we have in the EQ in the 5010, it's going to trigger our EQ loop on the output side. So if we have, for example, if we have 4 service type codes, or in the example given here, we have 6 of them. So if we have 6 service type codes for this EQ, we're going to trigger this EQ to happen 6 times. And that's exactly what we want here. We want each one of these EQs to happen, and we want all of the data to come through, because that's what the 4010 implementation guides state. So once we have the EQs, you can see there's one last step that we need to do. Since we brought in the same EQ with several service type codes, we know that we have 6 service type codes in here. So therefore we also use the index function, and that just generates a sequential number that we can use in the choose function so that we can find the right service type code. So we use choose function to bring back the right service code for whatever the index is. If we look at our data, we can change this around so you know that we have the right mapping here. So our input data looks like this. We can tell it's 5010. We can see this EQ segment. There's a few other EQ segments as well. But on our 4010 side, we can see it's EQ 2 and 8. Here's the first one. It has a 9. So we run our map to test the clone function and our choose function. We build it. This tree is fine. Complete successfully. We take a look, and we can see here that we have an EQ segment for all the data on the input side. One EQ segment per service type code. At the same time that we're doing this, we'll also have to build a 271 5010 from a 4010 file. It has a similar issue. it's with the service type codes, but in this case it's not an EQ segment in the 271, it's an EB segment. So for 4010 it's a little more challenging. We have three segments here that all have the same information except for these service type codes. So the service type codes are here in our data. We have 33, 44, and 55, and there's a few other ones down here as well, but we can see that we need to combine these on the way out the door for the 5010. So we can see that we've done this. So let's take a look and see how we did it. So we'll go to our 271 map, 4010 to 5010, and we'll take a look at the 2000D loop. We'll start there. So if we take a look at the rule, you can notice we use the unique function. This is just to make sure that we only get unique EB loops. They should be unique. Trading partners should only send us unique EB loops, but just in case, I think some of our data was not unique. So at any rate, we have EBs on the input side here for our 4010 data, and we have EBs on our output. So let's go into this functional map and see what our next step is. This rule looks a little bit complicated. It's really not that bad. All we're doing is we're comparing all of the data that's in this EB segment that we triggered the functional map with all the other EB segments that we have in our data. So we brought in the entire dependent HL loop, as well as this individual EB loop, and we're comparing the two, and the goal of this is we want to find the parent EB segment, and by parent what we mean is the first one. So we're using a lookup function to find this first EB segment, and let me go to the 4010. So on our 4010 data we can see we have these three segments that are the same, but we only want to bring one of them back. It really wouldn't matter which one we brought back. We're just going to bring back the first because that's the way the data is coming through. As long as we only bring one, because what we want to do essentially is trigger the functional map only the amount of times that we want to build EB segments on the output side in the 5010. So we can kind of group these together and say, all right, we want 1, 2, these two look the same, so that's 3, and this single one. So we're going to want 4 EB segments on our output side. And you can see that we've already done this mapping, it's already working correctly. So what we did here is we found one of the EB segments that has all the same data, and later what we do once we have one EB segment is we're going to pull in all the codes, service type codes, that have this same EB information. So the simplest way to put it is that we're finding the parent EB segment, and we're going to populate all the service type codes for all the similar EB segments. So we compared everything in this EB segment. All these codes except for the service type code, you'll notice, is the only thing missing from this comparison. So if we go inside this functional map after we've gotten the parent, we're going to compare the current EB segment. So each one of these EB segments or loops has been triggered by the 4010 data. So we're going to check, since we already have the parent blob, we're going to, or the whole EB segment, we brought it in as a blob, we're going to compare it to the current EB segment and see if this one actually is a parent. We only want the first one. So this first one is a parent, and since it is a parent, we are going to map it, and then once we get to the service type codes, we're going to use that same logic that we used to find the parent to find all of the other service type codes. And in this case, you'll see we use an extract because we want multiples. We want all the service type codes and only the unique ones. And if there happens to be no service type codes, we want to trim right just in case there's any spaces, we'll remove them. So we used all the same logic that we used to find the parent, and this brings in all the service type codes for similar EB segments. And we'll change this around just so you know we have mapped this correctly. So now on our output side we should see 66, 44, and 55. And we'll go ahead and build this map. We save, build, run the map, complete successfully. And now we can see this is a 66. If you have any questions on any of the lesson that you saw today or WTX in general, please look us up on Middleware Academy. Thanks.